My last factoring problem I have is not actually grouping, but I did all the factoring together in the same lesson, so it's still lesson 8.4. And the examples that I have to go through with you are sums and differences of cubes. So these are patterns to look for. I'll cover some of this up so there's not as much to look at. Okay, look at one thing at a time here. If I have a sum of perfect cubes, where I have a cube plus another cube, like this. If I can sort out what number is being cubed or what variable is being cubed, like this 125 is 5 cubed. And 27x cubed is, 27 is 3 cubed. So 27x cubed is 3x cubed. 3x times 3x times 3x, 5 times 5 times 5. And if I add those together, this is how you'd factor that, as this pattern. A plus b times a squared minus a times b plus b squared. I just substitute whatever the first cubic term is, everywhere there's an a. And the second part, here I'm going to consider this to be a, I'll consider this to be b. So everywhere there's a b, I'll put 3x. And I substitute into this pattern. So I factor this as 5 plus 3x times, when I square the first one, 5 squared minus 5 times 3x plus 3x squared. And when I substitute, I use parentheses. The reason for that is when I square 3x, I want to make sure to square the 3 and the x, because 3x squared is 9x squared. I just want to make sure I don't accidentally find myself with a 3x squared there. That's not the same. And I can rewrite this simplified as 5 plus 3x times 25 minus 15x plus 9x squared. Whenever you factor a sum of cubes or a difference of cubes, the trinomial that you get cannot be factored. So you just plug it into the pattern and we're finished with that. I have another example here, and it's a difference. And it's not obviously a sum of cubes, but hopefully you notice right away that there is a greatest common factor here. So first thing I would do, grab my difference of cubes, oops. Example. First, with this one, I have a greatest common factor, and it's 2x. So if I factor out 2x to the fourth minus 2x pull 2x out front. Where that pen's going, huh? Try again. There, that's better. Let me reduce 2x times x to the third minus 1. And these are perfect cubes. This is 2x times x cubed minus 1 cubed. So I have a slightly different pattern. Because the first term is minus, it matches. This is a difference, so the first one is subtract. The next sign is opposite. These are always opposite. And the last one is always added. So for this one, I'll consider A to be x and B to be 1. So everywhere there's an A, I'll put x, and everywhere there's a B, I'll put 1. And this is factored as 2x times x minus 1 times x squared plus x times 1, that's just x, plus 1 squared, that's 1. And the trinomial cannot be factored further. So these are for factoring sums and differences of perfect cubes. You could use your power table. That may help you determine whether you have a perfect cube or not. I linked that with your Unit 8 page in Canvas.